Hello and good day to all. My name is Nik Adilah Hanin. I'm from Universiti Malaysia Perlis. So today we will discuss a little bit about the artificial intelligence. So I think before we move on to other lectures that discuss more or deep regarding AI methodologies, I think it is better for us to review back what is the fundamental of AI, the concept of AI. Okay, so to start with, I would like to start with this quote from John McCarthy from 1956. He said that AI or artificial intelligence is the science and engineering of making intelligent machines, especially intelligent computer programs. So John McCarthy was an influential computer scientist known for his significant contribution to the field of AI. So he is the one who coined the terms of AI or artificial intelligence in 1955 in one famous Dartmouth conference. Okay, so it was said that was the birthplace of AI as a field. So McCarthy laid foundation aspect of AI, and he developed the programming language Lisp, which became widely used for AI research. So additionally, he made a very significant contribution to the concept of time sharing of computers and the idea of cloud computing. So his research on AI covered a lot of topics, including machine learning, symbolic reasoning, and what would later be known as logic programming. And then for this all the contribution, McCarthy received numerous of awards, including the Turing Award in 1971. Okay, so recently IBM also defined the definition of AI as a technology that enable computers and machines to simulate human intelligence and problem-solving capabilities. So this is what IBM defined what is AI. Okay, so actually AI have a lot of subfields. Okay, so under AI we have machine learning, and also we have deep learning, and recently we have another subfield, what we call generative AI, which is the subfield of deep learning. Okay, so machine learning is a subset of AI that use advanced algorithm to automatically learn and detect patterns in dataset. So after a while, the researchers start research or propose what we call a neural network technique that is the foundation of the next subset of machine learning, which is deep learning. So deep learning is a subset of machine learning that use multiple layers of artificial neural network to extract high-level features from large input data. So this is the techniques that is proposed to imitate the way the human brain works to recognize patterns and make decisions. Okay, so after a while, I think around 20 something, so generative AI was boom. So generative AI is a subject of deep learning model that generate content. It can be text, it can be images, or it can be programming codes even, by learning from big data set, whereby this learning process will create output that are novel, realistic, and often mimicking the human creativity and decision making process. So basically that is the overview of AI. Actually, AI overlap with many other fields such as data science, but what we view here today is the fundamental component of what is AI. Okay, So AI is consists of two types. One is the weak AI, the other one is the strong AI. Okay, so weak AI is also known as narrow AI. This kind of artificial intelligence is designed to perform a specific task or solve specific problem without cognitive abilities of humans. Okay, so this weak AI respond to a specific situation, but they do not actually pose actual intelligence or consciousness like a human being. Okay, so they will operate under a limited set of constraints or contexts, focusing on a narrow set of tasks. So for weak AI, it just focuses for a specific task that is trained from a specific data and possess a very limited constraint and context. For example, here, let's say virtual assistant is one of the weak AI. Recommendation system, which is depends on what kind of recommendation system is it. A book, a movie, for example, is a very specific task. Image recognition software, which is might be specific to certain type of images, such as face recognition, okay, and many more tasks. Okay? But different with strong AI, which is also known as artificial general intelligence, AGI. So this strong AI refers to AI system that possess the ability to understand, learn, and apply knowledge to equal to human intelligence, meaning that this AI should be able to think, to decide, and to act like a human, similar as a human. Okay, so this AI should be able to perform any intellectual task, self-aware, and capable of experiencing consciousness. Okay, it's like human, they have conscience, but this strong AI is actually still theoretical and has not been achieved. So I think up until now, all the researchers are working on the weak AI so that one day we can produce a strong AI. Okay. Okay, let's see how human brain learning works and in comparison with the machine learning. Okay, as a human, so we learn from historical experience. Everything that we gain, I think from our birth until now, is considered as experience, and everything that we do, we think is, and what we decide is based on historical experience or past experience. Okay, from past experience, we learn how to make some induction and gain certain knowledge, so that this knowledge and experience can be used to solve a new problem, which can contribute to the future action. Okay, so that is how our human brains work. We learn from past experience. Okay, so in our mind, we do some induction, and then we come up with some set of rules and knowledge, and after that we try to apply this experience with the new problem come to us and try to solve it, okay, in the future. So the machine learning actually works in similar way, with a little bit different in terms of process or technical or the method used. Okay, so let's say for machine learning, what they need is a big historical data. Okay, so from this big historical data, so we will feed all of this data to a machine, whereby machine, or what we call computer program, will learn and try to discover pattern from this data. So this thing will be done by using a mathematical model or statistical representation to come up with the rules. Okay, so this is what we call modeling. Okay, we come up with some set of rules using mathematical function or statistical representation in very easy way to describe it. Okay, so there we get a model. So this new problem will be fit to this new model that learn from big historical data and try to predict the future attributes. So basically, human brain learning and machine learning have a similar process, but maybe different technique in how to gain the knowledge and the model and how they solve the future problems. Okay, so there's a different and the similarity there in human brain learning and machine learning. So machine learning consists of many types. So this is the main 4 type of machine learning. So first we have supervised learning. Okay, so supervised learning is a method where it train a model based on a labeled data, which is the correct output, with a predetermined features or categories. So the data that you use to train supervised learning, to perform supervised learning, must have a labeled data and must have a predefined categories. So the model will learn from the to map inputs to the outputs. For example, you want to predict the house price based on features like size and location. So your data must have numbers of features and the value of features like size and location, and then it also must have what is the house price based on that size and location. So that is what we call label data. Okay, so there are already correct output attached or annotated to the data, so that at the end we can do some evaluation to see if our model perform correctly or accurately or not based on this label data. Okay, so another type of machine learning is unsupervised learning. So this type of learning will train on a model, to identify patterns in a data without label outputs. So this kind of learning we only focus on the underlying structure of the data. Let's say you want to segmenting customers based on purchasing behavior, or you want to cluster type of fruits, for example. Okay, so we would like to group things into similar patterns without knowing how many cluster is there, or what is the actually the features that what is the features they are included inside the data set. Okay, so that is unsupervised learning. So for semi-supervised learning, usually this technique use both labeled and unlabeled data for training. Okay, so typically this semi-supervised learning is performed if you have a very small amount of labeled data. So usually when researchers or anybody that use semi-supervised learning, they have a very small amount of label data, and in order to get this data is highly cost. So that's why they perform label and use label and unlabeled data to perform machine learning which is known as a semi-supervised learning. So let's say you want to improve accuracy of language translation model with limited label data, so you can use this semi-supervised learning. Okay. The last category of machine learning is reinforcement learning, which is a technique that learns to make sequence of decision by receiving rewards or penalties for action to improve further action. Okay, so this is a type of unsupervised learning, if I'm not mistaken. Okay, so we have a robot learning to navigate a maze through trial and error. So every time the robot do some action, they will be given rewards or penalty at the end. They will try to adjust their action to gain more rewards. Okay, so this kind of learning we will discuss further after this. Okay, so for supervised and unsupervised learning, the difference is very significant, whereby the supervised learning use a training data that has label, and usually the supervised learning is very useful for classification and regression. But I think everyone already know that in reality that the data doesn't always come with label. So if you want to produce a very accurate result, so usually this data is must be manually annotated, or you can use any algorithm or techniques to label the data, and of course you have to evaluate the data first before you use further in supervised learning. Okay, such as classification or regression. Alright, let's say these are the example of supervised learning. Okay, we have, let's say you have input data of these images, an apple, and then you have annotation, these are apples. Okay, so let's say you have you feed this data to and do the training and do the modeling and everything. And then you feed a new images and you try to determine the category of this image. So having the data, the input data, the labels, and then you do the modeling, so you will get the prediction. So this will be the supervised learning. Yeah. So for unsupervised learning, the training data only has features, so no label. So let's say you only have data that only have just about no label. Maybe you can do the unsupervised learning. You can perform clustering or an association rule to detect patterns among the data. Okay, let's say for example you have an input data. There's no annotation of what kind of categories belong or contained in the data set. Okay, so you perform unsupervised learning. So you try to the algorithm will try to figure out what is the will detect or discover patterns from the input data, and finally they will come out with a group of for example here, group of fruits or things to be detected or recognized. Okay, so we have another category of learning, which is semi-supervised learning. So semi-supervised learning is a semi, so it use both label and unlabeled data to build better models when the acquiring of fully labeled data is costly or impractical. So our aim is we use a small amount of labeled data, so this data is used to guide the learning process, and then after that we use the larger set of unlabeled data to capture the underlying structure and the distribution of the data. So this technique like self-training or label propagation or clustering can be used where the model uses its own prediction to provide pseudo label for the unlabeled data. Okay. So if for example, if a fruit is in the unlabeled set is round and comes in various color, it's not typically an oranges. So the model might tend to label it as a apple as a conclusion. Okay. So this pseudo label, what we call, are then added to the training set. Okay, to the training set, and then the model is retrained. It will be an iterative process. Okay, it must be repeated. So you have input data, which is not labeled, only partially labeled, and then you fit into the machine learning model, unsupervised learning model, and then after that we feed unlabeled data, and then finally you can get the prediction. Okay, that one will be the semi-supervised learning. Next will be the reinforcement learning. So reinforcement learning is one of the machine learning techniques, okay, whereby the model learns to make a sequence of decisions by receiving rewards or penalties for action to improve the future action. So first you will start in a state. So the current situation, the state refers to the current situation of the agent in the environment. After that, based on its policy, the agent will select an action to perform in the environment. Okay. For example, by using this example, I think everyone know about the Mario Brothers game. So let's say the Mario is the main character or the agent. So if number 2, you take an action, meaning you have to go left or go right or jump or stay still. So you have to take action based on the strategy for of a current policy. And after that, you will receive a reward or penalty from the environment. So the environment will be give feedback to the agent in a form of a reward signal. Okay. So reward can be let's say here in Mario game, it can be you receive a positive reward, the gold for example, or you encounter a mushroom which is a negative reward, or you can get this largest reward which is from the flag. Okay, so this is a type of things whereby the agent will receive reward for achieving a desired outcome, or negative reward if make mistakes. So after taking the action, so the environment will change to a new state that reflect the outcome. Okay, so let's say for example in this Mario game, if you gain a lot of gold, for example, you become bigger. I don't know, from bigger, if you encounter a negative reward, you become smaller. So that will be a new state of the environment. Okay, and then based on the reward received, the agent will update its policy to favor action that leads to higher rewards in the long run. So this main training process involves various of algorithms to update the policy for future making decision. Okay, so this one is reinforcement learning. So usually it involves an agent, not just a software. Okay, so it will involve an agent and then the movement or actions. Okay, so that will be the reinforcement learning. So basically, machine learning algorithm is divided into 4 main categories: supervised learning, unsupervised learning, semi-supervised learning, semi-supervised learning, and reinforcement learning. So I think every machine learning type, there are tasks that suitable for each type of machine learning. For example, for supervised learning, usually we use for classification and regression. Unsupervised learning technique is for clustering and other pattern detection. Semi-supervised learning is for classification, regression, and clustering as well. And reinforcement learning is focusing on controlling an agent. Okay, so there's a lot of machine learning algorithm that are available. I think many of you are familiar with all these machine learning algorithm. Okay, so let's say for classification, there are a few machine learning algorithms that are commonly used, like logistic regression, neural network, decision tree, SVM, and so on. So some of these algorithms can be used for regression as well. Okay, and then also we have a few partitioner and hierarchical clustering, and we have other pattern detection algorithm, okay, like PCA and GMM, and then a lot of the combination of both supervised and unsupervised learning, which is semi-supervised learning, that require a little bit different of machine learning technique. And then we also have reinforcement learning that focusing on controlling, which usually use network related or network based algorithm. Okay, so one of the algorithm in supervised and unsupervised learning, which is neural network, is the fundamental of the evolution of machine learning that leads to the deep learning process. Okay, so actually this neural network works mimicking or imitating how the human brain works. Okay, so in human brain, the neuron consists of three parts, which is the dendrites, okay, and then the cell body, and then the axon. Okay, so dendrite is the branch-like structure that receives signal from other neurons. Okay, so the neural signal transmission begin at dendrites, so they will receive chemical signals from the other neurons. Okay, so this signal will trigger electrical impulse that travel to the cell body. So there are a lot of signals that travel to the cell body, and then this signal will be accumulated in the cell body, okay, or what we call soma. So this electrical impulse received through the dendrite will travel to the cell body. It will integrate with all the incoming signal. So the cell body will determine whether to fire an action potential. So if the threshold is reached, the action potential is generated at the axon hillock and rapidly travel along the axon to its terminal. So here the arrival of the action potential will cause the release of the neurotransmitter into the synaptic gap. Okay, so this neurotransmitter will cross over to the next neuron's dendrite, attaching to the receptors and initiating a new process to the next neuron. Okay. So finally, this signal will be conveyed into motor neuron in the spinal cords, and then it will transmit the signal to the muscle, and then cause the muscle to contract and perform any desired movement. Okay. So this is how a biological neuron works. So the artificial neural also is designed to mimic these biological neurons. Okay, so an artificial neural network, or ANN, works like a simplified brain model. So it will process the data through a layers of artificial neuron, so each will connect to many others. So data will enter through an input layer, okay, and then each neuron will assign different weight to the incoming data. So and then this input and weight will be summed up, and then bias will be added to this weighted sum, and then this total value will be transformed by an activation function, so determining whether and how strongly to pass the signal to the next layer. So this process is repeated across the layer and then until they reach an output layer. The last layer will be the output layer. Okay, so this at the end will provide the final result. So artificial neural network ANN will learn by adjusting the weight and then bias to minimize error, and they kept adjusting this weight and bias to improve the accuracy of the output layer. Okay, so that is how the neural networks work. So the neural network has been evolved since 1940s. So the first model of ANN is proposed by McCulloch and Pick in 1943, and after that in 1955 a single layer perceptron were proposed by Rosenberg, and then in 1970s the exclusive OR problem were highlighted, and then here the back propagation algorithm was first introduced by Verbos in 1974. And then in early 80s until 90s there are a lot of refinement being proposed regarding the back propagation algorithm. And then the recurrent neural network that can handle sequential data is proposed by Rumelhart, Hilton and Williams in 1986. And then in early 2000s there are solution was proposed for vanishing gradient problem in the neural network. And then since 2010 the hardware advancement such as GPU has enabled training complex model on a large data set, and since then there's a explosion or expansion of deep learning, which leads to the evolution of generative AI that we are using right now every day. Okay, so deep neural network are advanced version of artificial neural networks with many layers. So that's why they use the term of deep, which is referring to the depth of the layer in a neural network. In a simple neural network, there are only one input layer, one hidden layer, and an output layer. But for deep learning, it refers to the depth of layers of a hidden network in the neural network. Okay, so this deep neural network can handle more complex tasks by processing data through multiple layers of neuron. So each layer will learn different features of the data at various level of abstraction. Okay, so by utilizing multiple layers, it will produce a very complex architecture. This will enable automatic feature extraction and better performance on challenging tasks. For example, in image recognition, the first few layers might detect edges. In the middle layer might identify shapes, and the deep layer can recognize the entire object. So the deep learn and improve by adjusting the connection between layers based on the accuracy of their output compared to the non-example. So they will compare the output with the annotated or non-example, and then they try to adjust the or improving the weight and bias in the previous layer. So it become better at predicting and making decision the more they train. Okay. So deep learning require a lot of data, and then also require computational resources compared to a simpler neural networks, because due its complex architecture. So backpropagation is a fundamental algorithm used to train ENN. So it's a method that systematically update the weights and bias in neural network to minimize the difference between the actual output of the network and the desired output. Okay, so first the input data is fed throughout the network layer by layer. First layer, second layer. Okay, until you reach the output layer where a prediction is made. When you perform the what we call forward pass. Okay, so input layer will is the layer that whereby the input data is fed through. Okay, so every input layer will be multiplied with the weight, and then the weighted sum will be passed through the activation function, and then activation function will decide if the weighted sum exceeds certain threshold and decide if this neuron will fire out or not. Okay, so this thing is done to every layer until it reach the output layers. Okay, so this is what we call forward propagation. Okay, so after that, when we reach when the information the signal reach the output layer, the prediction is compared to the actual desired output. Okay, and the difference or the error will be calculated using the loss function. Okay, so and then the error is then propagated back through the network, starting from the output towards the input layer. Okay, so it will move on until towards the input layer. So during this what we call backward pass or backpropagation, the partial derivative of error with respect to each weight and bias are calculated using the chain rule of calculus. So this process will determine how much weight and how much bias contributed to the final error. Okay, so the weight and they will be adjusted, and then here the optimizer is used to adjust the weight, find the optimal weight to decrease the error. So this adjustment is done by optimization algorithm like gradient descent. Okay, stochastic gradient descent, for example, where a linear rate determines the size of step taken in direction that minimally reduce the error. So this process will be repeated for many iterations over the entire dataset. So the forward propagation will be done, and after that backpropagation will be performed to adjust the weight and bias until you reach a certain amount optimal value of the prediction. Okay. So this backpropagation will enable neural networks to learn from training data by iteratively adjust the weight in the response to the error to optimize the network performance for a given task. Okay, so this kind of algorithm or mechanism allow the network to learn complex pattern and make the accurate prediction. Okay, so that is the how backpropagation works in deep learning. So the deep learning, the concept of deep learning provide the foundation, the main foundation that power many of most advanced generative AI models. So deep learning involves training a large neural network to recognize pattern in data, and then this model learn to represent and process data through multiple layer of abstraction. So this capability is crucial for what we call generative AI, that require a deep understanding of complex pattern in order to create a new realistic output. So generative AI actually is a type of AI that can generate new content. It can be from text or images, or music codes or coding, based on the pattern and information it has learned during its training phase. Okay? So generative AI are trained on a large dataset and learn to mimic the underlying distribution of the data. So this generative model can produce new content that share properties with the training data. So meaning that what you train will be the foundation of what this generative model will produce. Okay, so this model, generative AI models, are used in very many of field. So there's a lot of utility in creative, technical, and decision-making application. So these show the versatility of the generative AI model. Okay, so there are the most famous or common generative AI is a ChatGPT. I think everyone always use this. It is developed by OpenAI. So GPT model 3 and 4 are capable of generating coherent and contextually relevant text based on prompt. So other than this, it can also generate images. Okay, so for text, it can generate essays, creative fiction, or even codes, programming codes. So many people or user use this to create content. I think mostly in the form of text. It can be used as conversational agent and coding assistant. Okay, so this is one of the popular generative AI. Other than that, we also have Deep Dream, a generative AI developed by Google. It's a computer vision program that modifies images using the inherent patterns of the image. So it will produce images that resembles a dreamlike appearance. So this kind of generative AI can use for image modification and pattern recognition research. So that is generally what is AI is all about. A little bit, a brief introduction and some history and how the AI evolved from machine learning to deep learning and to the generative AI. Okay, I think we can learn more about AI in our next video. Thank you.